Okay, so as far as completing the square goes, we are going to start with one where we already know the answer, so we'll know that this whole completing the square trick thing is actually working. Okay? So let's see, I need a nice simple one. X squared plus 4x plus 3 equals 0. All of you can factor that and solve it, right? Two numbers whose product is 3, whose sum is 4, 3 and 1. Factor it, solve it, you're done. But we're going to complete the square to do it. And I'm just going to kind of run through the trick once or twice to familiarize you with it. And again, there are problems in your book that you can practice, and you should, because we will be using this, and I will expect you to know it by later in the semester. Okay? Good. To complete the square, first off, you isolate the quadratic term and the linear term. So get rid of the constant. Bring it over to the right. So we get x squared plus 4x equals negative 3. Now, in order to make this work, your leading coefficient has to be 1. In this case, it already is 1, so we're good to go. Now you get to the fun math part. Look at the linear term. Coefficient is 4. You take half of that. What's half of 4? 2. Then you square that. What's 2 squared? 4. Add that. So you get x squared plus 4x plus 4. Half of that squared. All of you know your algebra, and algebra says if I add 4 to the left, I have to add 4 to the right to keep things equal. So I get negative 3 plus 4. Assuming you did this right, the left is now a perfect square, and you can factor it. Leading coefficient is 1, so it's x and x. Two numbers whose product is 4, whose sum is 4. 2 and 2. Equals negative 3 plus 4, which is 4 minus 3, 1. One trick I'll actually say, this is, again, pretty much the easiest one I could come up with. As the numbers get more complex and you have fractions and stuff like that floating around, assuming you do this step right, this will always factor, and it will always be 1/2 of this term. Half of 4 is 2, so it's x plus 2. So you can use that as a guide to check yourself. We generally rewrite this as x plus 2 squared equals 1. And now as far as completing the square goes, we're actually done. But we still want to solve the problem to make sure we get all this other stuff right. So we actually get to use a different method called the square root method. And essentially the idea is we have something squared equals 1. How do you get rid of a square algebraically? Square root. You always do the opposite. The opposite of a square is a square root. So, square root the left. But whatever you square root on the left, have to square root on the right. On the left, the square root and the square cancel, which is what we want. So we get x plus 2 equals, on the right, what's the square root of 1? 1 or negative 1. So we actually get two answers, plus or minus 1. The plus or minus is important. Make sure you put it there. Okay? And now solve that. Subtract the 2, and you get x equals negative 2 plus or minus 1, which gives me two solutions. Negative 2 plus 1, or negative 2 minus 1. Negative 2 plus 1 is negative 1. Negative 2 minus 1 is negative 3. This is a quadratic. How many solutions should you get? 2. How many did we get? 2. Again, way back here at the beginning, if you had factored, it would have factored as what? X plus 3, x plus 1. You would then switch the signs when you set those terms equal to 0 and gotten negative 3 and negative 1. So the trick works, right? Easy, simple, good. Everybody like completing the square? No? Okay, good. I want to, like I said, I want to look at one or two more just to kind of get the idea in your head. So suppose we have 2x squared plus 6x plus 1 equals 0. We want to complete the square again. What's the first step? Isolate the quadratic term and the linear term, right? So in this case, subtract the 1 over to the right. So we get 2x squared plus 6x equals negative 1. Yeah. Now, we said in order to complete the square, leading coefficient has to be 1. This one isn't 1, it's 2, so we have to get rid of it. As far as it goes, there are different ways to do this. And I'm aware that all of you come from different high schools and have had a lot of different math teachers. Different math teachers do it differently. If you have done this before, ultimately, I don't care how you do it, as long as you do it correctly. I have the way I prefer to do it. Other people have the way they prefer to do it. I don't really care. I generally factor out the common 2, and then you're left with x squared plus 3x equals negative 1. I'm aware some people will divide by that. That's fine, whatever. I tend to think students don't like fractions. If I divide by 2, that's a fraction, and that generally messes people up. So we're going to avoid that as long as possible. Okay? Now do the same thing, focusing on the inside. Let's see, we have 2x squared plus 3x. Now we have to figure out what to add. 1/2 of the linear term. What's half of 3? 1.5. And then you take that and square it. What's 1.5 squared? Feel free to pull out your calculator. It's 2.25. Okay? So we get plus 2.25 equals negative 1. Yes, all of you here and at home, feel free to check your calculator. I'm pretty sure that's 2.25. Okay? But again, the rule, whatever we add on the left, we have to add on the right, right? So what do I add on the right?
2.25?
No. We didn't add 2.25 on the left. And this is the one trick, and again, this is why people do it different ways. Technically speaking, if you distributed this out on the left, I didn't add 2.25, I added 2.25 times 2, which is actually 4.5. I added 4.5 on the left, so I add 4.5 on the right. You can write it as a mixed number, fraction, decimal, I don't care. Okay. That's the one thing you have to keep straight in your head when you have coefficients that aren't 1. Again, if you want to do it the other way, that's fine. I like this way, so I do it. Now let's see. We get 2. Assuming we did this right, it's a perfect square. What's it factor to? X plus 1. We said if you did it right, you need 2 numbers that multiply to 2.25 that add to 3. And the trick is, it's half of this. Half of 3 is 1.5. So it's x plus 1.5 squared equals negative 1 plus 4.5, which is 4.5 minus 1, 3.5. Now you want to solve that. I don't necessarily want to take the time to solve all of this out, so I'm going to do it relatively quickly, and I'll leave the rest up to you. The one thing you have to make sure to do, we want to use the square root method again. In order to do that, you have to isolate this part that's squared, so you have to get rid of the 2. Again, like I said, you can divide it at the beginning, which generally gives fractions that confuse people, or divide it at the end and kind of save everything till the end. Divide by 2 on both sides, and you get x plus 1.5 squared equals 3.5 divided by 2. 1.75, there you go. And again, you can make that as a fraction or a decimal, I don't care. And now the rest I'm actually going to leave up to you, both of you guys at home and you guys here just for fun. Square root both sides, and then subtract the 1.5 over, right? And you should get x equals negative 1.5 plus or minus the square root of 1.75. We'll leave it like that. If you want a numerical answer that you round, throw it into your calculator and get it. But that's it. You clear on that? Good stuff? Isn't math awesome? Sometimes. Well, okay, then the question is, why do we care about all this? Why do we bother to learn how to factor and quadratic formula and complete the square and do all of that? Not just because some teacher told you you had to do it. In order to pass this class and graduate, you need to do it. Why is it helpful? Real world problems. Can you come up with a real world problem that involves quadratics? Anyone?
Numerics.
Pneumatics?
Yeah.
Anything else?
If you throw something up in the air, it's gotta come back down. So
That's a quadratic?
the quadratic one, parabola is coming
Yeah,
down.
parabolic motion, projectile motion. You all know what that is? When you throw something up, it comes down, right? What's the graph of a quadratic look like? We will do this later in the semester. So again, if you don't, I'm sure you all do know it, but if you don't know it, regular quadratic looks like that. You can also flip that, and it will look like that. This right here looks like something going up and coming down, which is projectile motion, which means there are projectile motion equations that we can solve with quadratics. And we want to spend at least the last few minutes of class now kind of working on that. The one thing I do have to point out, especially because this is going to be on YouTube and I don't want to get 4,000 people telling me I'm wrong. I mentioned throwing something up in the air and it coming down, correct? And then people always show you a graph and say, oh, well, it's projectile motion, which means you throw it up in the air and it comes down, right? Is that correct? No. This works when you take an object and throw it straight up and it comes straight down, which means the object is literally going straight up and straight down. That makes it look like the object is going sideways, which is wrong mathematically. The object is actually going straight up, straight down. So then why do we use this graph? Anybody have any idea?
Height and time.
Essentially, you are taking, for lack of a better way of saying it, take a picture of something when it goes straight up and straight down, and then kind of put those pictures in a line. And over time, you'll see the object going up and coming down. So this is actually the graph of an object going straight up and straight down over time, which turns out to be a parabola. But again, I just have to mention, when we throw an object with going it straight up and straight down, it does not actually make a path like that. The path is actually straight up and straight down. Solving other things with parametric equations is a different class, 172. Do that, after this class. Feel free to sign up. I'll be teaching it. 172. You should take it right here at Martin. Okay, good. That's my little commercial. There is a standard projectile motion equation, which you should know. I'll mention it repeatedly throughout the semester. But for right now, we can at least set it up. H of t equals negative 16t squared plus v sub 0t plus h sub 0. Both for those of you here in class and at home, that's a t, that's a t, that's a plus, that's a plus. Don't get too confused because they kind of look alike. Negative 16t squared plus v sub 0t plus h sub 0. First off, do people actually know what v sub 0 and h sub 0 mean? No? Okay. H of t means the height of an object at time t. So t is time, your variable, h is your function, your height at a given time. So these t's are just your time. Plug in a time, get a height. Makes sense. V sub 0 and h sub 0, the subscript 0 is actually a standard math thing, and actually science, physics, and all that thing. When you see a subscript 0, it means an initial condition. So for the purposes of this, v sub 0 is the initial velocity of the object. When I throw it in the air, when it gets fired out of a gun, whatever. Initial velocity, h sub 0 is the initial height. So if you're following along, if I told you I had a projectile motion equation, h of t equals negative 16t squared plus 80t, what is the initial velocity?
80.
80 feet per second, correct?
Oh, okay.
What is the initial height?
Assuming 0 or ground level.
The initial height is the constant right here, which is 0, which means it just gets launched from the ground. Straightforward? If we kind of went in reverse, and I said, I throw a ball straight up, with initial velocity of 80 feet per